Hi everyone, I am Francine from Huawei Global Training Center. Today, let's discuss the design of Docker-based microservice architecture. Building microservice involves the following questions. How does a client access microservice? How does microservice communicate with each other? How can user locate each other microservice? What is the microservice fails? Now, let's check each question in detail. In a monolithic application, all services run located and can be called by a client UI directly. In contrast, the microservice architecture splits a monolithic application with a set of smaller services by function. These microservices are generally Java processes running on different VMs. How does a client access microservice? Suppose that there are many services running in the background. If removing, updating, or upgrading, any of them requires a redeployment of the entire application. This obviously goes against the idea of the splitting, particularly when it comes to mobile applications. Those services change faster than other types of applications. In addition, calling multiple small services consumes a great deal of network resources. Therefore, communication between a client and backend service is typically mediated by an intermediary, known as an API gateway. All the requests from a client first go through an API gateway, allowing the client to access microservice in the foreground. The API gateway aggregates background service, reducing traffic and improving performance and security by filtering and traffic control. Each service is an independent Java process running on a different VM. Therefore, services interact with each other using the inter-process communication (IPC) mechanisms. Therefore, many well-established APC mechanisms. The two most common using methods are synchronous invocation of REST, JAX-RS or RPC double APIs, and asynchronous invocation of Kafka, Notify, and MetaKey APIs. In the microservice architecture, each service generally has multiple cups of loading balance to propose. A service can be taken offline anytime or providing with more nodes and handle temporary traffic spikes. How two services sense each other? How are services managed? Basically, service registration is managed in a distributed manner using Zookeeper or similar technologies. When a service instance starts up, it's registered with Zookeeper or a similar framework. The service instance sends HitBit requesting to prevent its registrations from expiring. The service instance registration is refreshed in real time. Clients can only obtain the network location of a service instance using Zookeeper based on a custom algorithm. Users can catch service instance information located to improve performance. When a service instance is shut down, Zookeeper sends a notification to the client. For the monolithic architecture, the biggest risk is that any change to a small part and application might require an entire monolith to be rebuilt and deployed. However, a distributed architecture pattern can perfectly solve this problem. Hytrix, shown in the picture, is a tool designed to improve the error tolerance capabilities of distributed systems. If a system consists of service location chains, we must ensure that the following link does not impact other links. For this, there are a variety of methods available: retry mechanisms, traffic control, loading balance, and degrading, local coaching. Okay, let's recap. In this section, we discussed the questions involved in building microservices and how a client accesses microservices and how microservices communicate with each other. Well, that's all for this part. Thanks for attending.